just a bit of a chemist view on the origins of life. I'm not a biologist. I'm not an evolutionary biologist. I feel like nowadays I can understand those fields a little better, but coming at it from molecules, thinking about how molecules are made and how they are arranged in space, let's talk about the difficulty of the naturalistic view of creating a replicating molecular system. And so we have these big questions that we think of when we look at the universe around us. You know, what is the purpose of my life? What happens when I die? These are critical questions that my students have and my colleagues. And one big question is, how did life begin? And so this ultimate question needs to be sort of put into context. And so I have this worldview map that I use with the students, and it always sparks very good conversations. And so, you know, every person asks questions about these areas at some point in their life, either origins or the meaning of life, purpose, morality, not just is there right and wrong, but how would we know what right and wrong is? And then destiny, where do we go from here? And all major belief systems or worldviews have had to answer these questions. And so this table will outline 6, I would say, internally consistent worldviews. There may be some disagreement about whether they're internally consistent or not, but this will at least line out 6 of them. And so let's go through this very quickly. This isn't the whole talk. This is just setting it up. So, you know, the origins part, that's where we get into the age of the universe, the age of the earth. And really there's 2 answers for that in different worldviews. There's young universe, young earth, and there could be some discussion about those particular years. But again, that's not the focus of the talk at this point. Or there's the view that it's old and that science has given us pretty good estimates of the age of the universe and the age of the earth. One way to explain those differences is whether physics is uniform in the past or not. And so that's, that goes with those 2 views. The exception on that physics is uniform in the past is that initial expansion. It's part of the Big Bang or the creation event that we like to think of. And that provides some evidence for a broken physics in the past, meaning that the universe expands much faster than the speed of light. And so that's a new kind of physics. And so that does suggest that there's either a multiverse or some other realm other than our naturalistic universe. And so that's why, sort of tongue-in-cheek, over on the left side, I have evidence of a multiverse from the initial expansion. And for the statistical folks that want to get rid of fine-tuning, they say, well, we have an infinite number of universes. And so they have n goes to infinity. But even in the Bible, when it talks about in the beginning God created, we have the spiritual realm and the physical realm. And so we have at least n is greater than or equal to 2. Okay, so we have at least the spiritual and the physical. Again, this is sort of a range of views here. I'm sorry? I think we have a mic that's hot. Okay. And then we get down into natural selection on random variation. Now that's the specific natural selection only operating on random variation. And that would be what some would call microevolution. And so this one across the board is agreed by everybody. This is why we take the full range of antibiotics, because we know that we're going to create superbugs if we don't. And so this is something that, even though there's argument about that, I think when you dig into everybody's writing, you see that they do affirm this small piece. What they don't affirm is this, that there's limits on novelty. And so on the left side of this worldview map, they would say that there are no limits on novelty, that this random mutation in natural selection can create whole new body plans and go from bacteria all the way up to all the biodiversity that we see today without any external intervention. That's the next row. So is there any agency of biological change? You know, these 2 here would be a strict materialist. They would say no limit on novelty and no need for an agent in the biological realm. this is really where the views start to spread apart. Over here on the right, we have God intervening multiple times to create plants and create animals and create mankind. In the middle, we have a sort of a blend of these different views. This panpsychism we'll talk about in a minute, but we have theistic evolution, which would be called God-gifted creation. And then we have intelligent design, which would be an unknown intelligence has intervened in some way. We see evidence for that intervention. I put yes up here, that there's a limit on novelty, that God has interacted and created large jumps or discontinuities that we see in the biological realm. This yes-ish, I would say that they would say that God gifted creation at the beginning, and then the dominoes fell the way God wanted them to fall. And so is there a limit on novelty? Well, maybe at the beginning, that God had to shake the box of dice just the right way so that when it spills out, we get the full natural development of all of the biodiversity that we see, and that God did not need to intervene in between any of those epochs. So this is just a range of views on origins. Then we have the meaning, that purpose is defined individually and is illusory over on this side, or discovered in relation to the creator on this side. And I don't have sharp divisions on this view between the different camps. Moral duties over on the left would be totally socially constructed, and over on the right would be objective and divine, and listed in the scriptures. Again, various views in the middle. With destiny, we have the destiny of the universe, which would be just thermodynamic heat death. And over on the right, in this area, heaven, hell, and a new creation. And individually, from dust to dust. And then on the right, an everlasting soul with or apart from God. Again, with a bodily resurrection in Orthodox Christianity, so the soul reunited with the body in heaven. So where does this, well, let's go through the labels for all of these. So you may have heard me talk about some of these labels earlier: theistic evolution, intelligent design, old earth creation, young earth creation, strict materialism, and panpsychism. And these are some representatives of those different views. This panpsychism was Thomas Nagel's view, and maybe some Platonic realists. And he was just, he just couldn't buy that, that values were material. He didn't see that the value structure of life, that justice and morality would come from atoms banging into each other. So he couldn't buy the strict materialist view, but he also wasn't going to become a theist. So he just didn't, he got right up to the edge and he said this would point towards theism. But he did something that I think is really a shame for scholars to do. All of the arrows were pointing towards theism, and he got right up to the line of crossing over into theism, and he said, but that's not science. As if that matters. You know, the thing is, if all the arrows are pointing towards theism, at least talk to a theologian. Talk to somebody on the other side of that line and start to engage in them. Don't build an artificial fence and say, I can't go over there. And so he stopped there, and he, in his answer to how these, how mind emerges and how values emerge from a naturalistic point of view, was that there's some mental properties in nature. So all of nature has some mental properties in the atoms, and that when they are put in a certain form, a certain size brain, a certain structure, that these mental properties emerge. And so this is an emergent view of the brain, an emergent view of values. So that's panpsychism, if you haven't heard about that before. But it's not a strict materialist view, but it's also not a theistic view. Then we have websites, and in his book is Mind and Cosmos. And then I have this section here to kind of characterize the debates that are going on between these different groups. And I put it, who fights whom and what do they fight over? Well, when Nagel published his book, the strict materialists called him a heretic, which I think is funny because that's religious language. They said that he had left the reservation of strict materialism, and they, you know, they were very critical of him, and he was very critical of them. So it was definitely heated exchange. Over here, the young Earth and old Earth would fight in the quotes, over uniformity of physics and over theology, and writing, the writings of the scripture and how to interpret those. The Biologos and Discovery Institute, I mean, they have good dialogue, but to use the fight term, they're discussing whether interventionism is actually necessary or not, and whether it's the Christian God or just mind, some impersonal external mind. And then the theistic evolution folks and the panpsychism folks might discuss or disagree over the necessity of God or just mental properties in nature. So this is my worldview map, and it's always nice to take whatever question you're dealing with and see where it lies on this map. And so let's get back to the original question, how did life begin? Let's look to see where it fits on this map. And I think it fits on these two rows right here. Are there limits on novelty in nature? And is there an agent that's required? So these would be the barriers. Are we on the left or the right side of those vertical lines? Now I'll go ahead and give you the conclusion of the talk in case we lose power or what have you. And so my conclusions are that homochirality and chemical agency point to the right. They push us to the right side of all three of those lines. And aboutness, which we'll explain in a minute, and information points to the right. And so the things from a chemical point of view and looking at the chemistry of life, it suggests strongly that there's a chemical agent involved, because it just, the things that are necessary to do the chemistry of life don't happen in just some random mud puddle. Okay, so let's talk about this. Let's explain these conclusions and we'll come back to them. So this, I've used a couple of blog posts that are available on reasons.org. So I've just kind of highlighted some of the materials that you already have access to. And so hopefully I'll be doing, again, some exposition, maybe some translation of these concepts. So let's talk about homochirality. This is a blog post that was written quite a while ago by Hugh Ross, but this is just one of the most obvious things for a chemist, that when we have chirality, it's very, very difficult to do a chiral synthesis where you have a pure result. And so let's talk about what chirality is. It comes from handedness. So you see you have two hands and they are mirror images of each other. Okay, that means also that they can't be superimposed. There's no way. Now you might say, well, look, I can get the thumb and the fingers to line up, but the palms are facing each other now. I've had to turn this hand around and slide it over. And so that's not a superimposition. To superimpose them, I'd have to get them on top of each other where the thumbs were on top of each other and still facing you. And so our hands have handedness. That's where this word comes from. And so do our molecules. So here's the amino acids. You know that amino acids are those building blocks for our proteins and enzymes. So our whole body depends upon amino acids and proteins and enzymes. And every one of those is chiral. Every building block of those enzymes and those proteins is chiral. So if you look here, the way we constructed this molecule, if I'm looking down this hydrogen, I can go from this red, green, blue to the right. It can rotate to the right. Or if I'm looking down this hydrogen carbon bond, red, green, blue goes to the left. If you're having a hard time rotating this in your mind, okay, think of a boat propeller. So if you're going to take a boat propeller, which way do you make the blades? You could make the blades like a right-handed screw or a left-handed screw. It's the same thing with these molecules. So when these molecules were put together, they were put together in a certain way so that they always had like a right-handed screw, righty-tighty, okay? And so that is the same type of screw for every amino acid in our bodies. And not just our bodies, but plants too, and bacteria and fungi and so on. All of life molecules are homochiral. And so here's a picture of the amino acids. Just here's one is alanine. And so when we're drawing these molecules, the straight lines are in the plane of the paper. So this oxygen double bond is in the plane of the paper. This bond to the OH is in the plane of the paper. This is a carbon-carbon bond and the carbon-nitrogen bond, all in the plane of the paper. But look, this is a wedge here. That's coming out of the paper. It's meant to come out towards us. And there's a choice, right? If you were to pick that molecule, you could have drawn it the other way. It could have gone into the paper. You still have the same molecule, but that's the chiral center. And so you could have drawn it coming towards you, or you could have drawn it with dash, which means it goes back behind the plane. And these would be the two molecules that you would get if you were to just synthesize this in a round bottom flask in the chemistry lab. You would get what's called a racemic mixture. And so in a chemical synthesis, entropy would drive these molecules to a 50-50 mixture. And so in chemical synthesis, we would get a 50-50 mixture of both chiral molecules. But in living systems, we have 100% this and 0% that. And we've shown in the past that this is important. There have been several drugs that when they ramped up production and they didn't pay attention to chiral synthesis, then they tested that drug on humans and created enormous havoc on the body. There was a famous case of a drug that was made for morning sickness, and the trials were good because the trials used homochiral molecules, but then they ramped up to production and they put it out on the market and it created enormous birth defects. And so that was the ramification of having a racemic mixture, or a 50-50 mixture of the chiral molecule. It created terrible results in the body. And so this is a paper that's cited in Hughes' article, and it's from an Origin of Life conference in Santa Monica, California, back in the 90s. And it's a great article to read. If you just click the link in that blog post, you can read the article. But let me zoom in here on the conclusions. They essentially said that the group broke into two camps on homochirality. Now, Miller and Botta believed that life began on Earth, and Bonner and many of the physicists at the meeting suspected it originated in space. So why do they have to go to an extraterrestrial source for homochirality? Well, Bonner explains. He says he spent 25 years looking for terrestrial mechanisms for homochirality and trying to experimentally investigate them, and he didn't find any supporting evidence. He said terrestrial explanations are impotent and non-viable. And so again, that's a chemist's perspective to say that there's nothing in nature that's going to just naturally give us a homochiral set of amino acids. And we haven't even talked about the sugars that are needed. All of the sugars are chiral as well. So all of our carbohydrates, all of our sugars, all of our starches have chiral centers in them. And all of those sugars, those pentose, those 5-membered ring sugars, go into RNA and DNA. So RNA and DNA are also chiral. So this topic covers everything that's important to life chemistry. And so the heart of the extraterrestrial camp's misgivings about a terrestrial origin is that entropy drives molecules into a racemic mixture. So that racemic mixture is that 50-50 of both right and left-handed type molecules. And so then I think this is a different article, although no, I think it's later in that same article. Hugh looks at some of these external sources. They went out and found that there's a slight excess of chiral molecules in some asteroids, and they say that space can produce a mixture of chiral molecules that's enriched in one enantiomer. An enantiomer is like the right hand or the left hand. So one of these two molecules is an enantiomer. And they said that it has 1.34% enantiomeric excess. Okay, what does that mean? Well, that means the best spaceborne model that they found can produce a 50.0067% of this type of molecule and a 49.9933%. So that's how much it's swung in one direction. And they're saying that that has solved the homochirality problem, and it has not. Okay. Now there's other kinds of chemistry. This is a blog post by Fuzz a little more recently, January in 2019, talking about not just amino acids and so on, but the basic molecules of life. And he said really they had three goals in mind in studying prebiotic chemistry. They want to see if there's a proof of principle. So do mechanisms exist that can produce amino acids, that can produce simple sugars, that can produce the various other molecules that are necessary for life, and are there mechanisms, at least in nature? Do we have the right starting materials and so on? And in Fuzz's opinion, he says that they've done a pretty good job of the first two, but the third one is giving them trouble. And so he says over the last 6 to 7 decades, origin of life researchers have been wildly successful with respect to the first two objectives, that they have a proof of principle and a mechanism. I put the proof of principle in green because, yeah, we do have the starting materials in certain places, but the mechanism is still shaky in my opinion. But anyway, Fuzz's opinion is that, yes, they've shown in principle that these reactions can take place. But the third objective, geochemical relevance, is when they run into trouble. So let's talk about what geochemical relevance means. Is there a location on Earth that represents the apparatus that we have in the chemistry lab? This is my apparatus for doing fractional distillation. This is my research. I work in solvent blending, solvent blend prediction, and also solvent formulation. So whenever we have, and it's related to precision cleaning. So let's take a everyday example. You have an artificial knee, and that artificial knee has been 3D printed, and it's been cleaned. Well, that's got to be very clean if it's going to go into your body. And you don't want any kind of, especially you don't want any kind of oily residue or fingerprints on it, because the beauty of a titanium oxide layer is that it's incredibly compatible with your bone cells, the osteoblasts. They will impregnate that oxide layer of the titanium and actually make a titanium bone bond. And that's an incredibly strong bond. So this surface must be titanium oxide with no residue. And we have some good ways to clean those things. But if those solvents are toxic to the worker, harmful to the environment, they receive regulatory pressure. So if they pull one of those solvents off the market or put other kinds of regulatory pressures on that cleaning process, that's where my research group comes in, and we will come up with a different solvent blend, or we'll evaluate other kinds of cleaning processes to see if it can get the same result. And so in my solvent formulation work, I do a lot of fractional distillation. And so let's think about this for a second. I've been very selective in my starting point. I pick the best reagents, I isolate them from their environment, and I have a very careful heating profile. I also have a carefully designed thermal gradient, and it's also isolated from the environment. These molecules travel up this fractioning column, and they evaporate and condense and evaporate and condense and evaporate and condense. And so this column gets gradually cooler as it goes up. We have an intentional condensation step. So we have cold water, so chilled water in this area. It's also isolated from the environment. And then we have selective fractionation. So I take off fractions whenever I think about, is that enough of this fraction? What's the boiling point doing? If the boiling point changes, then I swap out these little vials here and collect my fractions, because I have a purpose for doing this. And that's what's not shown in all of this, is the analysis and the decision making. I'm actually crafting this process to get the results that I want. And this is one of the simplest operations in chemistry. is to separate compounds and to purify them. We do this at the sophomore level. So these are people that don't even have chemistry degrees. This is an associate's degree level work. You do this in 2-year colleges and get an associate's degree in science. And so this is not the most complex PhD, required activity, and yet even for this operation, this is nearly impossible in nature. And so, where are you going to get these pure compounds? Where are you going to get this isolation from the environment? Yes, we have heat sources in nature. We have thermal vents and so on. Where do you get the temperature profile that doesn't decompose the molecules that you're trying to create? So this is not an easy problem. And so that's why Bonner concluded that terrestrial explanations are impotent or non-viable. But I don't think going to space, that's kind of like a God of the gaps argument, but it's not God. It's saying, well, there may be something out in space that's going to solve this. We know it's been solved because we know there was a naturalistic explanation. Well, I think you're just starting from a naturalistic point of view, and you're never going to consider anything else if that's your argument. And so the history of chemistry demonstrates that agency is necessary in all of these. There were decisions made by the agent, by the chemist, in choosing the glassware, choosing the heating profile, choosing the measurement device, choosing all of these things. And so this, when we talk about agency, we're talking about a free agent, someone who's able to make decisions and construct the situation. So I think homochirality and chemical agency definitely point us to the right in this diagram. Let's now look at some of the other ideas related to DNA and to the geologic timescale. So let's go back a little bit to the Hadean era, where essentially the advent of rock roughly marks the beginning of the Archean aeon. So we go from an accretion disk around the sun to a very hot and molten surface, and then the Earth starts to cool, and we have some rocks that are about as old as 3.8 billion years, but that's about it in terms of the time scale that we can measure. And so from 3.8 billion years to the beginning of our fossil record with cyanobacteria at 3.5 billion years, that's a really narrow window. So I think a lot of times people look at the age of the Earth and say, well, there was plenty of time for DNA and the molecules of life to come about because we've got billions upon billions of years. And the answer to that is no. We see that the morphologies of cyanobacteria have remained much the same for these billions of years. So what does that tell us? We have a window from 3.8 to 3.5. This novelty window is very narrow. So at the end of that window, we have proteins, DNA, and RNA, and we have this cyclic dependency. We cannot replicate DNA without proteins. Think about that. We cannot replicate DNA without proteins. We cannot make proteins without RNA. And so we cannot replicate DNA without RNA. And so this is a cyclic dependency that just appears at the end of this window. And we cannot make DNA without carbohydrates. We cannot make RNA without carbohydrates. We have those ribose sugars in there. And those ribose sugars are chiral as well. So we had to have homochirality and these molecules of life and this scheme, this central dogma of biology present in just 500 million years. At the very beginning, when the universe was, when the Earth was very inhospitable to life. So we don't have 3.8 billion years for this to figure out. We have 500 million, which is a really narrow window. And it's sometime within that window. I'm not saying that it was gradual within that 500 million years. It really does appear to just be abrupt. And so let's think about this just backing up and thinking about the information that's present in DNA. And let's go back. Do you remember this alphabet cereal? I had it when I was a kid. I absolutely loved it because you would look in the bowl and there might be some chance that your cereal would spell a word. Okay. This example is from Frank Turek's presentation. I don't have enough faith to be an atheist. He's come to our campus quite a few times. If he's ever in your area, it's definitely a good talk to go see. It's in the book of the same title as well. And so you come into breakfast, you see the alphabet cereal has spilled all over the table. And you look, and upon closer inspection, you see a message here. And you zoom in and it says, take out the garbage, Mom. Okay, and so this information has the property, the philosophical property of aboutness. It's about something, okay? They have rules of grammar. This is an imperative clause. So it has meaning outside of the words. Out versus in, that's a purpose, right? That's teleology. Take out the garbage. It doesn't belong in. And then garbage is a value statement. So there's values buried in this. And then Mom, we have a source of the message and we have authority. And nothing about these letters contains these external things. These letters are about something that's external to the medium. And so the medium does not have aboutness. The letters are just cereal materials, you know, wheat and so on, some sort of emulsion that's pushed through these dyes, and they make letters that we recognize, but the food isn't about garbage or about Mom or about an imperative clause. Just like DNA isn't about replication. DNA is just a molecule. It has connections to things that are external to it. RNA doesn't have an aboutness. Yes, it does aid in producing proteins, but it doesn't know that. It's just a molecule. So the medium itself does not have aboutness. The information in the medium is about something. And I think a lot of times we'll go to this and we'll say that that statistically this is an improbable message. Well, yes, certainly statistics is improbable, but the statistics misses the point. You know, if you took the 26 characters of the alphabet plus a space character plus a carriage return and line feed, and I think I included 2 of them, the probability of this message just falling out of the box would be 1/28. That's the total number of space, you know, the guess space. And since there are 25 characters, that's 1/28 to the 25th power. And that's 10 to the negative 37 probability, okay? So, but that kind of misses the point. That's just the probability of getting any 28 characters to fall out of the box. And in fact, if it didn't have any meaning at all, and you just had 28 characters with some spaces and some line feeds, it'd be exactly the same statistics. And so this is what the fine-tuning people say that try to get away from the fine-tuning. They say it's just statistics, that we just get this universe that we get because there's an infinite number of universes, but they're missing the information. They're missing the aboutness. There's certain things in our universe that are about something that's external to the universe. There's value, there's morality, there's authority, there's all kinds of things that aren't contained in the universe. And those are the clues that push us out of the statistics and out of the naturalistic point of view. So there's things that, when we say that these molecules have aboutness, they're about things that are external to them. What do you call those things that are external? Well, I call them aboutees, right? If this process is about something else, what is that something else? I just coined this phrase, aboutees. So the things that this central dogma is about, it's about replicability, survivability, and then all the other external and immaterial properties of organisms, including our minds, including our value systems, including our eye color. You know, the molecules in our DNA will give us a certain set of genes, and those certain set of genes will code for our eye color. But eye color is not a property of the DNA, okay? The DNA will produce a particular eye color, but it's not about eye color. It's just a set of molecules. It's the medium for that information. And so this aboutness is, it's amazing that it exists at all, because in all other chemical experiments that I do, my molecules aren't about anything, okay? They're just molecules in my beakers. And so there are no messages that come out of my beakers and so on. I have to supply all of that as an agent. It's also amazing that this suddenly appears in the first 500 million years. So this really is something that causes you to pause. And so this is interesting. It was predicted 3,300 to 3,500 years ago with the writing of Genesis. And so I think a lot of times Christians get criticized. We say, wow, this is an amazing issue. God did it. And our critics will say it's a God of the gaps, that they identify a gap and then theists put God in there. But that's not happening at all here, okay? We didn't learn about homochirality first and then say God did it. This was a prediction. So we go back and look at Genesis, we see that this was written 3,300 years before science even existed. And it says, God said, let the earth sprout vegetation. You know, this is an intervention. This is predicting that we will see a discontinuity in nature. And in fact, there's been several of them. So this is a nice little graphic that I got from Reasons to Believe. You know, there could be some discussion as to where these dividing lines are. I've put some dividing lines in here that make sense to me. You might look at the biblical record and put them in slightly different places, but this is some of the scientific evidence that we see. And here's that cyanobacteria and other phototrophs. It says 2.7 billion years ago, but these stromatolites here in microfossils were also produced by cyanobacteria. So the evidence for cyanobacteria can go back, you know, arguably back to 3.5 billion years. And so we see these discontinuities that are listed out in Scripture in Genesis 1. And so we should see, when we go to the scientific record, we should see if we can get data before that discontinuity and after that discontinuity, that it won't be a smooth transition, that it'll be a break. That we won't have anything and then we will have something. And I think the most obvious one, these are difficult way back here, the first 4 days, but day 5 is the most obvious one.
Could I have?
Yes, please, go ahead.
I'm sorry, just as you're discussing this, I'm not that well versed in these topics, but there was an experiment done, I believe it was in the 50s. There was the test tube, they claimed to have developed proteins and such. Could you address that?
Yes. The Urey-Miller experiment, yes. It took ammonia and carbon monoxide and maybe methane, so a reducing atmosphere. And that would be one we expect here in this area, this early part of the Earth, a reducing atmosphere, very hostile to life, but yet seems to be one that these cyanobacteria could handle. But before the cyanobacteria, this would be the Urey-Miller experiment, where they took an electrical discharge, sort of to simulate lightning. They had methane, carbon monoxide, and ammonia, and they got glycine. Now glycine and maybe some other amino acids. And this is what Fuzz was talking about when he said the proof of principle was pretty well developed. Now the Urey-Miller experiment has run into some criticism that it wasn't exactly representative of the early atmosphere, like maybe they had the concentrations of ammonia or methane or whatever too high or too low, etc. But other experiments have been done to kind of show the proof of principle that amino acids are what I would say thermodynamically stable. So yes, you can make some of these molecules of life with these kinds of engineered experiments. And that's what Fuzz was talking about in his 2019 blog post, that the proof of principle that these molecules are thermodynamically stable and that you get the reactants in the right conditions and these products will come out, okay? But what misses the point is that the apparatus and the concentrations require an external agent. They're so improbable to occur anywhere on the Earth that it has to it's pointing to the hand of a God, a creator God. So even if there was sort of a naturalistic use of things that existed, methane and ammonia and so on the Earth's surface, that it would still require an active agent to get the concentrations and the locations and the heat and so on just right.
Thank you.
Okay, good. Did that help?
Yeah, when I was in junior high, they were.
Yes. Yes, and so that's the Yuri Miller experiment, and it's still in textbooks today. And the sad thing is they still haven't updated it. So many times they still have it as if this has solved the problem. They don't talk about homochirality though, typically. And those amino acids that were produced by those kinds of experiments are racemic. They're 50-50 right and left. And so that's not going to be compatible with life. So we still haven't solved the homochirality problem. As I was saying too, that's a discontinuity going from non-life molecules to life molecules, but the largest and most data-rich discontinuity is the Cambrian Explosion. And so that's right here at the beginning of day 5, where we go from sponges on one side of this discontinuity, and then we have many of the phyla that we still have today. You know, you have creatures with complex backbones and skeletons, segmented legs, you have teeth and eyes, you have all kinds of things that just appear as a very discontinuous, non-gradual way right here at the beginning of day 5. So, you know, if I were in a discussion with somebody and they wanted to argue about, you know, 1 through 4, where we have very little data, you know, I'm not going to be as dogmatic about that and say, yeah, okay, neither you nor I have a lot of data about these early discontinuities, but we have a huge amount of data on this discontinuity in the Cambrian Explosion. And that was predicted by the scriptures. So plant life, animal life. And that's not a God of the gaps if it was predicted. Okay, and then also humankind. We are so different. And so this is the current, you know, active studies right now. It's going on. William Lane Craig's looking at it. Fuzz and Hugh and the folks have written, you know, Who is Adam? Definitely a good book to get. There's been discussions recently with A.J. Roberts and Dr. Swamidas and so on, those folks that are working through this human origins area, and that's the beginning of day 6. So I'm not versed on that. I'm still sort of following their discussions. So these discontinuities were predictions made before science existed. They were not responses to scientific difficulties. So we are not guilty of a God of the gaps logical fallacy here. And these are falsifiable claims. So if the Bible said that we had these discontinuities and we look back and we say, no, animals have always existed together with plants, together with bacteria, you know, all the way back. If this was, or this was gradual, matching this sort of microevolution just on a long time scale, and everything took a really long time to develop, then I would think the claims could be falsified. So these are falsifiable claims. So these observed discontinuities argue strongly for external agency, because what caused the information to appear in the genome for animals? And so I think aboutness and information points in this direction as well. So the most reasonable view, in my opinion, is the old Earth creation view. It reads the book of nature and is open to that in terms of what we observe around us. It acknowledges that there's an external agent that comes in and that external agent has contacted us, has communicated with us through the scriptures, and that we can look into those scriptures and find our relationship to the Creator and can find meaning and can find a root, a strong root for morality. That digging into scriptures can give us hope for the future of a new relationship with God, a repaired relationship with God through Jesus Christ. And that the difficulty of our own rebellion against God and our own plugging of our ears to ignore his message to us has consequences, and that we're warned against those consequences. And so this is where I think this falls down with the evidence. And so this chemist's view of the molecules of life still pushes me over to these yellow regions. I haven't seen anything that pushes me towards a materialistic worldview.